Dear students of grade 3 secondary, welcome to our math program. Today we have statics. Today we have exercises on moments. Now, what is the moment about a point in plane and what is the moment about a point in space or by using 3D coordinate system. Now, with the first example. If the force F equals 2I minus 3J and equation of its line of action is 3x plus 2y equal 0, then the moment of the force F about the point A 1 and 2 equals negative 7k equals 7k equals negative 1k or equals 1k. Now, let point P belongs to the line of action of the force F. And let x equals, say, 2. Then y equals 3 multiply 2, divide by 2, then y equals negative 3. Then the point B is 2 and negative 3. Now, what about vector AB or vector R? The position vector R or vector AB equals vector B minus vector A. Vector B, 2, negative 3 minus vector A, 1 and 2. Then vector AB equals 1 and negative 5. Now, the moment vector M about A equals AB vector cross F vector. AB vector 1 and negative 5 cross 2 and negative 3. Now, 1 multiply negative 3 minus negative 5 multiply 2 in direction of K. 1 multiply negative 3 plus 10 in direction K equal 7K. Then, the moment of the force F about the point A equals 7K and you can choose letter B. Another exercise. In the opposite figure, the flagpole of height 12 meter is pulled by a force F of magnitude 13 Newton, acts in the direction of AB ray or AB vector, then the moment vector of the force F about the origin point equals 48I plus 36J equals 48I minus 36J equals negative 48I minus 36J or equals negative 48I plus 36J. Now we have a force of magnitude 13 Newton act in the direction of AB ray or AB vector. And we have point A, B, C, and D. Now, since AB vector equals B vector minus A vector, then AB vector equals 3, 4, and 0 minus 0, 0, and 12. Then AB vector equals 3 minus 0, which equals 3, 4 minus 0, which equals 4, and 0 minus 12 equals negative 12. Now, we have the magnitude of the force, but what about vector F? Vector F equals norm vector F multiply the unit vector AB. Then vector F equals 13 multiply 3, 4, negative 12 over square root 9 plus 16 plus 144. Then vector F equals 3, 4, and negative 12. Now, the moment of the force F about O is vector MO, which equals vector OB cross vector F. Vector OB 3, 4, and 0 cross vector F 3, 4, and negative 12. Now, vector M about O equals the determinant IJK 3, 4, 0, 3, 4, and negative 12. Then the moment equals negative 48 minus 0I minus negative 36 minus 0J plus 12 minus 12K. Then the moment about O is equals to negative 48I plus 36J. Then we can choose letter D. Another exercise, if vector F equals 2I plus LJ minus K, this force acts at the point A, the coordinate of point A for negative 2 and 0. And the moment of vector F about the origin point is equal to 2I plus 4J plus 16K, then L equals 2, L equals 3, L equals 4, or L equals 5. Now we have a force F and we have the moment about the origin point. We can use the vector R or the position vector of the point A with respect to the origin point. Vector OA equals vector A minus vector O. Vector R equals 4, negative 2, 0, minus 0, 0, and 0. Then vector R equals 4, negative 2, and 0. Now, vector M about O equals R or OA cross F. Vector OA cross vector F. 2I plus 4J plus 16K, which is the moment about O. Vector M about O equals the determinant IJK for negative 2, 0, 2, L, negative 1. Now, we can expunge the determinant. 2 minus 0, I, minus negative 4 minus 0J plus 4L minus minus 4 or 4L plus 4K. Then 2I plus 4J plus 16K equals 2I plus 4J plus 4L plus 4K. Now, from the equality, 4L plus 4 equals 16, 4L equals 16 minus 4, which equals 12, divided both sides by 4, then L equals 3, and we can choose letter B. Another exercise, if vector F equals negative 1, 3, negative 2 acts at the point 4, negative 1, 0, then the component of the moment of vector F about Z axis equals negative 8, equals 3, equals 11, or equals 13. Now we have a force and the position vector of a point 4, negative 1, and 0. Then moment about O is a vector equals cross product of vector 4, negative 1, 0 and vector negative 1, 3, negative 2 equals determined I, j, k for negative 1, 0, negative 1, 3, negative 2 equals 2 minus 0i minus negative 8 minus 0j plus 12 minus 1k. Then the moment equals 2i plus 8j plus 11k. The required is the component of the moment of the force F about z axis. The component equals 11 and we can choose letter C. In the opposite figure, ABCD is a square of side length 2 meters. Two forces of magnitude 4 and 3 kilogram weight act along AB ray and AD ray, respectively. If the resultants are and L is the length of the perpendicular from point E to the line of action of the resultants R, then R equals 5 kilogram weight and L equal 1.5 meter. R equals 5 kilogram weight and L equal 1 meter. R equal 5 kilogram weight and L equal root 2 meter, or R equals 5 kilogram weight and L equals 1.2 meter. Now, what about the magnitude of the resultant of the two forces 4 and 3? The two forces 4 and 3 are two perpendicular forces. Then the resultant equals, or the magnitude or norm of the resultant equals square root 3 power 2 plus 4 power 2, which equals square root of 25 equals 5 kilogram weight. And we know that the sum of the moment of the forces about any point, say point E, equals the sum of moment of the resultant about the same point, or the moment of the resultant about the same point E. Now, negative 4 multiply 2 is the moment of the force 4 about point E, plus 3 multiply 1 is the moment of the vector or the force 3 about the point E, equals the moment of the resultant about the same point. The magnitude of the resultant equals 5, negative 5 because the rotation is clockwise, multiply the perpendicular distance L. Negative 4 multiply 2 plus 3 multiply 1 equals negative 5L. Then negative 8 plus 3 equals negative 5L. Negative 5 equals negative 5 multiply L. Divided both sides by negative 2. Then L equals 1 meter. Then the length of the perpendicular equals 1 meter and the resultant equals 5 kilogram weight. And we can choose letter B from the choices. In the opposite figure, the algebraic measure of the force of magnitude 80 root 3 Newton about point A equals negative 80 root 3 equals negative 800 root 3 equals negative 480 or equals negative 480 root 3 Newton meter. Now we have a force of magnitude 80 root 3 act at point C and vertically downward. What is about? The moment about point A. In the opposite figure, AB equals 8 meter, BC equals 4 meter, and the measure of angle 100, measure of angle ABC equals 120 degrees. Now, we can expand the line segments AB. Draw AB ray perpendicular to CD, which is the line of action of the force. And now, what is about moment about A? Moment about A equals negative 80 root 3 multiply the perpendicular distance from A to the line of action of the force, which equals AD. AD equals AB plus BD. Then we have moment about A equals negative 80 root 3 multiply AB plus BD. Then MA equals negative 80 root 3 multiply AB equals 8 meter plus BD. BD is the adjacent of angle 60 in the right angle triangle CDB. Then BD equals the hypotenuse cosine 60, or BD equals 4 cosine 60. Then MA equals negative 80 root 3 multiply between two brackets 8 plus 4 cosine 60. Then M about A equals negative 800 root 3 Newton meter. And we can choose letter B. Another example. If vector F is a force in the plane of parallelogram ABCD and MA, or the moment about A, the algebraic measure of the moment about A equals negative 18 units of moment, and MP equals MD equals 32 units of moment, then the moment about C, or the algebraic measure of moment about C equals 50, 82, 46, or equals 14 units of moment. Now we have ABCD is a parallelogram. And we know that the moment about A plus the moment about C equals moment about B plus moment about D. A and C are the two endpoints of the first diagonal AC, and B and D are the two endpoints of the second diagonals BD. MA plus MC equals MB plus MD. Then negative 18 plus MC equals 32 plus 32. Negative 18 plus MC equals 64. Then MC equals 64 plus 18, which equals 82 unit of moment. And we can choose letter B. Another exercise. The opposite figure represents a rectangle ABCD in which BC equals 12 centimeter, CD equals 5 centimeter. A force of magnitude 78 Newton acts at point D in direction parallel to line segment AC. Then the magnitude of the moment of the force about P equals 60, 360, 720, or equals 1440 Newton centimeter. Now we have a rectangle ABCD, and the force of magnitude 78 Newton act at the point D and parallel to the diagonal AC. Now, what about the moment of this force about point P? Now, we can draw PF perpendicular to the line of action of the force F. Then, MB equals negative 78 multiply BF. Negative because the rotation of the force about the point P is the direction of clockwise, and the perpendicular distance is BF. BF perpendicular to AC and perpendicular to the line of action of the force F. Now, BF equals 2dE. Then the moment of the force P about the point P equals negative 78 multiply 2dE. Now, what is the length of DE? DE equals the multiply of the two sides of the right angle divided the length of the hypotenuse. Then negative 78 multiply 2 multiply 12 multiply 5 over 13. 13 of the length of AC from Pythagorean theorem. Then the moment of P equals negative 720 Newton centimeter. Now, we get the algebraic measure of the moment of the force about P. But what is about the magnitude of the force about B? The magnitude of the norm of the force M about P equals norm of negative 720 E, or absolute negative 720, which equals 720 Newton centimeter. Then we can choose letter C from the given choices. Another exercise. If vector F equals 5i plus nj minus k acts at the point A, 1, negative 2, and 3, and the moment of vector F with respect to the point P, negative 2, 2, 4, equals negative 5i minus 2j minus 7k, then n equals negative 9, negative 2, 3, or n equals 9. Now we have the position vector r. Vector r equals vector BA, which equals vector A minus vector B. Vector r equals 3, negative 4, and negative 1. Since vector M about P equals R vector cross F vector, then vector M about P equals 3, negative 4, negative 1, cross 5, n, and negative 1. Now, by using the determinant, then negative 5i plus 2j minus 7k equals the determinant ijk, 3, negative 4, negative 1, 5, n, and negative 1. Then negative 5i plus 2j minus 7k equals 4 plus n in direction of I vector minus 2j vector plus 3n plus 20 in the direction of the unit vector k. Then 4 plus n equals negative 5, and hence n equals negative 5. Then we can choose letter A. Then n equals negative 9. Example. If the force F vector equals mi plus 4j minus k acts at point A, whose position vector with respect to the origin point is vector r equals 1, 2, and 2. And the component of the moment of the force F vector about y-axis is equal to 7 moment unit. Find the value of m. Then find the length of the perpendicular segment drawn from point O on the line of action of vector F. Vector F equals mi plus 4j minus k. Then the component of this force in direction x-axis, Fx equals m, and the component in the direction of y-axis equals 4, Fy equals 4, and the last component Fz, or the component in the direction of z-axis, equals -1. And the position vector r equals 1, 2, and 2, x equals 1, y equals 2, and z equals 2. Then, what is the component of the moment of the force about y-axis? Now, we have the component of the moment of the force about y-axis. The component equals z multiply f of x minus x multiply f of z. Then z equals 2 multiply f of x, which equals 2m, minus x multiply f of z, 1 multiply -1, equals the component about the y-axis is equal to 7. Then 2m plus 1 equals 7, and we get 2m equals 7 minus 1 equals 6. We can divide both sides by 2, then m equals 3. Now, what is the length of the perpendicular segment drawn from O to the line of action of F? L equals norm m about O over norm F. Then we must find the moment about O. Vector MO equals IJK, the determinant IJK, second row 1, 2, 2, and the third row 3, 4, and -1. Then the moment about O equals -2 minus 8 in direction I minus -1 minus 6 in direction J plus 4 minus 6 in direction K. Then the moment about O equals -10I plus 7J minus 2K. Now L, or the arm of the force, L equals norm vector M about O over norm vector F. L equals square root -10 to the power 2 plus 7 power 2 plus -2 to the power 2 divided root 3 power 2 plus 4 power 2 plus -1 to the power 2. Then L equals 3 root 17 over root 26 length unit. And by this example, we come to the end of our math program today.